It's somewhat of a paradox that if you receive a drawing from a survey firm, that although, as you see here, these are contours, the 208 metre and 212 metre with some intermediate or minor contours running through here, these in fact are 2D contours. So if I pick one of these, notice that although they look like contour lines, they're made up of single, very short line segments. And if you have to work with a drawing such as this, and you want to extract point data, you do need to be aware that extracting point data usually involves extracting the data from a polyline, and so we need to turn the short line segments into a polyline, and I've done that over here. So there's our polyline line segment. Notice polyline. I put it on a layer contour 208, and what we're interested in is what's the elevation of that polyline, and I've set it at 208. So I've done the same here. That's an elevation of 208.8. This one is 209.6. If we move along to this contour here, see, that's the single point. So the way we try and deal with it is that we grab these and then in gCADPlus just join them and select that. We hope that's now one entity up here, one polyline, and then we just sort of carry on, hopefully grabbing all of these, and if we're in luck, we should be able to simply join them. And you might have noticed little flickers of pieces of the, that didn't in fact work. So let's come back. So we've got a polyline to that point there. I think, so it's not, in other words, it's not unusual for what you get from the surveyor not to do the job. Let's just take a few more and we'll try joining those. And so there's got to be a gap in here somewhere. Aha, there's the problem. The information we got from the surveyor is, and I'll move this out of the way, can you see? That's why it wouldn't join. And gCADPlus works really well. You just click and go here and move that one back on top. Now they should all be congruent and we should be able to join again. I hope you can see now that I think there's the missing ones there, a couple of other lines. So your surveyor doesn't always do a perfect job for you, but here's a polyline, and this is on a layer. This one should be, let me just pick one down here, that should be contour 210.4. So we go over here, elevation should be 201.4. I'm not going to finish it off, but the aim of this exercise is to produce a file that we can use, move to another tool and extract the point data. Then we're going to use another tool to try and model that surface. Well, I've found a tool that will take a DXF file from this drawing and process it and extract the X, Y, and Z coordinates from these polylines that we've worked on through here. So I need to go save as, and I'll change it to a DXF file, and I'll call it contours with 3D ACAD 2000 DXF, because the tool that I've discovered, found, will work with that file. So we'll save it, contours with 3D. So now I'll switch to that other tool. To be on the safe side, I think I will go to our custom DXF tool and just export that file. We'll call it our DXF tool contours, and we'll save it. overwrite it. And then if we go to the tool that I found called DXF, it's a free tool, DXF. So we say our DXF contours and we save them and replace that existing one, and there it is here. So we now have a file with 3 values, X, Y, and Z. And there's the Z value 208. And if we scroll down here, we should get to the 209. So we pulled out a heck of a lot of information from it. So now we're at a stage using the third tool. So we used gCADPlus. We did some editing. Then we used gCADPlus and exported a DXF file. Then we used this DXF2XYZ, a free tool, although you can get a much more efficient version of it if you pay a little money. And now we're going to use the final tool. We're going to use our free tool that produces a triangulated surface. When we click make that file, the file ends in an extension XYZ. So understandably, DXF2XYZ gives you a file extension of .x, y, and z, and we're going to replace the existing one. So I've got all the coordinates now in one file, but TinMaker that we're going to use next needs the extension TXT. I'm using Windows 11 here, so I've got to make sure using the view and the drop down that I show the full file name, and I'll need to rename that .txt. I could, as an intermediate step, rename it and call it .csv, because I really would like to move that into Excel and then add a new column. So let's tackle that little intermediate step now before we look at our TinMaker program. Well, I've opened Explorer, renamed after being in Excel, I've renamed it Contours and .txt. ACAD 2000 just indicates the easiest format for using where we're using a number of these tools, but I digress. Let's just open that up just to show. So we've got all of the information. Here's our contour value. This is the number, the left-hand column, which has come from Excel, and I've just added numeric order, increasing in number. So we've got the right file. Now we need to go to our TinMaker program, and here we are. The interface is not easy to work with, but we need to go to points, and we're going to import the points from that file that we just looked at, and we'll open it up. It says 1,300 points have been added, so these have come from a 2D polyline. We've associated an elevation with them, and we're going to check this delta value. You just experiment with. It's hit or miss. I tend not to change it, and it found some duplicate points there. And if I zoom out a little, you can see the contours that we had earlier. I'm not quite sure what these red points here are, but we can click on them, I think, and then right click and get the information, although that didn't show. So we'll put that to one side for the moment, because what we now want to do is to create a boundary around this. Remember, we're after some triangulation. We want a irregular tin network, so it's tools now, auto boundary, and we type in some sort of value. I tend to make it close to the total distance across here, but we'll just say OK. And it's created a boundary. Now the next step is to create all the triangles. So let's do that. We'll triangulate. And there we are. What this is showing us is water will run off and there'll be a small valley there. And once we get here, a big, deep valley through there, and so on. So that is now a triangular network, and we can move that into gCADPlus. I think if I go back to here, there's our data. Just to refresh your memory, there it is showing the shading and contour lines are generated from the file. So that's what we've got. And back into here, we can now export that information to gCADPlus and work with it if we need to.